Hi, welcome to Math 331, the little questions. What I want to do today is just start a little bit with the purpose of the class, what we're going to do, some of the class mechanics. These are the questions you're all interested in. What's nice is there is no fixed curriculum for this. So we have an enormous amount of flexibility in terms of what we look at. Most of the material I teach most of my students, they never use in their entire life. Yeah, I'm a little bit more honest sometimes than a lot of professors in terms of I will admit to you. Or you have classes like Calc 2. Does anybody know the big lie of Calc 2? That you can integrate. We work really hard to find functions you can integrate in closed form. Most functions can't be integrated in closed form. Now, we can do a lot with these special functions. The purpose of a class like this is just general problem solving. So the specific problems you look at, you're probably not going to use either. So that's not going to change. But the thought process, that's going to be what's most important. And so what I really want to do is I want to have a lot of discussions in class. How should we approach this? The goal is not to see how many problems we can solve in a semester going through at warp speed. The goal is to really talk about the thought process. How would you attack it? What's a good question to ask? If I'm stuck on this, what's a related question I might be able to answer? We have 5 to 6 students who are taking this class remotely at Amherst and Swarthmore. One of the things you may have noticed when you stay at Williams is we can't offer every class every semester or every year. We just do not have the professorial power. And so a couple of us are exploring across a bunch of liberal arts colleges, sharing classes while maintaining the liberal arts experience. So this is still somewhat experimental, but the goal is to eventually have a wider, more diverse course offerings more consistently. So we will have a couple of days where they will Skype or Glow in. For the most part, I don't use Glow because this way when OIT sends out emails saying we've now changed to Glow 2 or whatever, I can just hit delete because I write my HTML code directly, which is why my web pages look like something from the 1990s. But we will occasionally use that just for some Skyping technology for people to join in for a couple of sessions. All right. So just introduction and objective. So not surprisingly, the first objective is to learn problem solving. As I said, emphasizing the techniques and asking the right questions. It turns out in a lot of mathematics or just life in general, the hardest part is asking the right question. Once the question is asked, frequently anybody who's been similarly trained knows how to solve it. I could have been prosecuted for plagiarism when I was a grad student. I wrote a handout for my students on something called Benford's Law and the Fibonacci numbers. And then it turns out I found almost identical a paper in the literature proving things in exactly the same order about a year or so before I was born. The reason is as soon as you ask the question, if you have the same training as everyone else, it's a natural chain of lemmas and what not to do. But the hard part is thinking that this is worth studying. So that's one of the things I want to do. There's a lot of problems we're going to look at that are cookbook problems that we may not really care about, but the methods we use to attack them will be useful for a bunch of other things. All right. So that goes into using these problems as a springboard, and then uphold the honor of Williams and the Liberal Arts Consortium of Online Learning, if I have the acronym correctly, in problem-solving contests. So there will be a contest organized by one of my friends from graduate school at the University of Rochester later this term. There is the Green Chicken, which I'll talk about a little bit later. There's the Putnam next year. There is a correlation between success in problem-solving competitions and success in mathematics and other careers. It's not a perfect correlation. There is a difference between looking at problems where you know there's a clever trick, a clever solution, and doing original research. Okay, so as mentioned, this is the Green Chicken. Does anybody here not know about the Green Chicken? The Green Chicken is what brings us cookies at Colloquium. So every year we have a contest with Middlebury. It's in the fall, often during homecoming, and they will announce the scores during the homecoming game. They will post who wins on the athletics homepage. There are very few schools in the nation that will post who wins a math competition on the athletics page. And Dick Quinn, who's in communications there, says, look, if it involves Williams and you keep score, I care. And this is, to me, it's absolutely wonderful. It really indicates the kind of culture we have here. So the Green Chicken was an unwanted wedding gift somebody got over 40 years ago. And they decided to have it connected to the contest. It wasn't clear initially if it would be for the winning team or the losing team to hold the Green Chicken. They eventually decided it should be a trophy of victory. Dick Quinn got the Boston Globe to write a story on this. And somebody in central Massachusetts contacts me and says that when they got married, they got a brown chicken. And am I interested? And this is my first year at Williams, and I said, I can be there on Friday. And so my son and I drove to central Massachusetts on the way to see my wife, who was back then still teaching at Boston College. And so Brownie is my family's personal property. It is not a certainty that she will take over if the green chicken is unavailable for a year to deliver cookies. She has had to do that once. It was a very stressful, difficult year for her. So we hope never to find out again if she has to come back into active duty. But you need to have fun with stuff like this. Course mechanics. So homework, which will typically be due on Friday, will be 15%, midterm 30%, final 30%, class participation 10%. So I really want an active class. I have an absolutely horrible memory. I work late at night, I check email very late, I'm often extremely forgetful during the day. If you say something wrong, if you say something stupid, silly, whatever word you want to use, I will forget. If you say something clever, witty, important, I will also forget. So what I want you to do is whenever you make a comment in class, even if it's a small, minor comment, send me an email the next day, or send me an email that day. If you want, even with your phone underneath the table. But this is a great way. I keep running tabs in my spreadsheets of who makes which comments. And this way, when I write letters of recommendation, I can be very specific. And sometimes you may think something is a really trivial statement, but it's not. It actually illustrates a really deep principle. It also gives me good feedback as to who knows what. Years ago, I was teaching a differential equations class here, and I asked the students, how many of you would like a review of 2x2 matrices? Because we didn't need to do linear algebra as a prereq for the course, but I can't teach differential equations without being able to do a little bit of linear algebra because I wanted to do systems of equations. And there was complete silence. So I go again. So nobody wants a review of linear algebra. Everybody's fine with 2x2 matrices. Silence. So I said, okay, everybody, you've got a clicker. Vote 1 if you want to review, 2 if you don't want to review. I'm not going to announce the results of the class. I'm just curious. I never said I wouldn't announce to other classes. 43% wanted a review of linear algebra. 0% was willing to publicly say. So, again, I cannot, this is one data point, I can't prove all classes are like this, but if there is something that you don't understand, if there's a step that seems unclear, odds are there's several other people in the room who feel the same way and would be very grateful if you ask the question. Not so grateful that they'll actually tell you that or show any emotion that they're happy that you asked, but they'll be happy. So please, if there's something that doesn't seem clear, if there's a point you want to elaborate on, please ask. Project Euler would be 15%. Project Euler is an absolutely wonderful website. It's basically on the boundary of mathematics and computer science. And the goal is to try to write a computer program in any language you want to solve the problem in under a minute. I don't really care if it takes a little bit more than a minute. If it takes an hour, that's fine. If it's taking a week, that's getting too long. So there are a lot of things in mathematics that are very trivial to do. If you want to factor a number, can somebody give me a trivial algorithm to find the factors of a number? I want a really bad one, the worst one you can think of.
Just go from 1 to the number and check if each one's...
Great! That's an absolutely horrible algorithm, thank you. Remember to send me an email. So you can just check every single factor up to the number. Oh my God, this is going to take forever. And if you have numbers of the size 10 to the 200, it's not going to be practical. And then you start thinking, can we do better? And there's lots of better things you can do. I'm not going to get into that now. So the point of this is a mix of both mathematics as well as computer science. How do you write good, efficient code? And that's something I really want to talk about. It's a skill I want you guys to leave with. I used to say that if you could program, if you knew statistics, if you knew probability, you would have a job when you graduate. You may not enjoy your job, but you would have it. Unfortunately, somebody did not get a job when she graduated from Monroe College, and she sued her institution. So because of that, I now have to be a little bit more careful in what I say. I will say it is highly likely you will have a job. Now, what's nice is with the Freedom of Information Act, you can download her lawsuit where she misspells words like tuition and claims a new type of discrimination, academic discrimination, that her 2.6 is just as good as someone else's 3.6, and the college is doing more for people with higher GPAs in terms of getting employment. I almost feel like she does deserve her tuition back if she could leave after 4 years thinking something like this. But I want you guys to get some computer programming skills. This is one of the most useful things. So when I talk to the students years after they graduate, the things that come to the top of the list are being able to program, and it's amazing what you can do with a couple of for loops and if statements, and the ability to speak in public. I often ask this question, is there anybody here who is planning on being a professional mime? I won't ask you to speak up because that could be against what you're trying to do. Okay, so no one is planning on a career in mime. So you are almost surely going to have to present. You're going to have to convince people, often who know less math than you, that what you're arguing is fine. And so I really want to try to work into this class the ability to present and do material like this. It's a great skill to have. It takes a while to get comfortable coming up to the board. I have prerequisites, linear algebra. If you don't have linear algebra, let me know, or I'll learn it tonight. If you know programming, that is a plus. If people want, I'm happy to have an entire lecture devoted to programming. It's an extremely important thing. I have some handouts online. I have some videos online. I don't really care what language you use. If you use certain languages, I'm more likely to be able to help you with the syntax. But whatever language you know is absolutely fine. There are some people who do Project Euler who try to do a different programming language for each problem they solve. These are the real hardcore CS majors. And I didn't even know that there was this many possible programming languages out there. I typically use Mathematica because I'm lazy, and that's what I used when I was an undergraduate. I used to know C well. Pascal, Basic, Logo, Fortran. Most of these things you've probably never heard of. There's a reason. They've been supplanted by better systems. But the ideas are the same. The difference is the syntax. I often have two windows open when I'm coding, so I can try something and see, is this the right syntax? Oh, okay, I need a square bracket, not a curly bracket. Stuff like that. So it's a skill I really want you to get from something like this. All right, so if I'm in my office, it's office hours. Feel free to come by any time. We will try to have a new building that is similarly designed as Bronfman, where you have a library and offices around it. The architects seem to be having difficulty. If only we had an example of a building where you could do this to show them. But if I'm in my office, just swing by. I will keep my schedule posted online so you have an idea roughly of where I am and if there's a meeting I want to get out of. Sorry, I didn't say that. The other thing is feedback. All I ask is please don't change the password. People have done that in previous years. But if there is a concern you have either about my class, something else at Williams, or generally, if you want to pass on information, here's a way to do so anonymously. You can log in as eefsmath@gmail.com, and the password is 1793Williams. And you can tell me how you want me to respond. You can say there's no need to respond to me directly. Just make this problem go away. And it could be something that I'm doing. It could be something that's going on elsewhere. I was at a school where a professor was teaching the wrong class. I won't say more as the camera is rolling. The students felt comfortable enough to come to me because they had had me for something else. And it was an interesting situation as to how do you deal with a professor who's not teaching what they're supposed to be teaching. They misread the course book over the summer and prepared the wrong course. So, all right. Our web page, this is also in the handout you have. I've already emailed you. If you haven't gotten an email from me, check your email. I send an email around 4 in the morning, I think. Let me know because that means you're not on the course email list. Each day I will post some additional comments based on things we're talking about. These are optional, but it's a great way to go a little bit further with the stuff we're looking at to see some connections. There's an opportunity to write a book. I am the problem editor of Pi Mu Epsilon. It is an undergraduate math honor society. And to celebrate its 100th anniversary, I thought it would be fun to have a collection of 100 problems, one related to a big mathematical event for each of the past 100 years. Also, I was the new editor. It was our 100th anniversary, and I was responsible for filling the problem sections. And so I figured if I split this into 4 sections, we only have 2 issues a year, this gets me covered for 2 years. So the book is now, we have the first draft done. There's a lot of chapters to look through. This is just a nice way to see some good mathematics. And so it's a great way to practice your writing skills. And again, technical writing is difficult. You want to be very precise in your word choices. You want to be very clear. You want to give people a sense of what's going on without overwhelming people with all the details. And it's really difficult to figure out exactly how much detail do you want to go into so that people understand enough so that they're convinced, but not so much detail that they just put it down in frustration as to, I don't really want to spend this much time on it. I also maintain a math riddles page, which is often one of the top sites when you Google math riddles. This is used by junior highs and high schools all over the world. If people are interested, this is another great avenue for some math outreach. And so there's a student-teacher corner where I write up with some of my students over the years how you might use some of these items in a course or in a high school or whatnot. All right, last is prepare for class. If I assign you readings, you must do the readings. One nice thing about a small class is it will be very easy to see who's going through the material and who is not. But it makes the lectures far more effective. Now, this class is somewhat in flux. Because it's a small enough class, I want to give you guys an opportunity to have input as to how things are structured. I may actually choose to have you do minimal reading so we can do things live. Now, what this means is that I may be looking at these problems for the first time in class, and I may get stuck too. And we may then have to say, okay, well, today in class, we just went around in circles for 50 minutes. But this happens in real life, and it's sometimes good to see how would you handle something like this. If you think that I am rigging it and pretending not to know how to do a problem, but I actually know it, you are welcome to secretly choose problems. Okay? I will let you vote on the cell phone policy. Option 1, if someone's cell phone rings, it's a warning to the class. Second time someone's cell phone rings in the semester, I flip a coin, and if it's heads, everybody gets a pop quiz. Third time, I no longer bother flipping the coin. Option 2, if your cell phone rings, you're responsible for bringing, say, munchkins and grapes or something like that for the rest of the class. So you have to vote publicly. Option 1, how many supporters? Okay. Option 2. Option 2 wins. My cell phone number is 617-835-3982. So if you want to have one of your friends try calling me during class one day, you are welcome to try that as well. I will often leave my cell phone in my office to minimize the chance, but the other thing is, are there any seniors here? Okay, I know sometimes people are doing job interviews or something like that, or you might have an important call that you're expecting. If that's the case, don't put your phone on vibrate. Keep the volume on maximum and just tell me before class that I'm expecting an important call. Okay? Any questions on the mechanics so far? Interesting. Interesting. It's not advancing. All right, there we go. All right. Not to where it started. Okay, is it back in focus?
Yeah, you're good.
Okay, so this is advice from my brother, Jeff. So he has 3 pieces of advice. First is party less than the person next to you. Based on where you're sitting, there's nobody directly next to you, so you're going to have to be very studious this semester. I apologize. Take advantage of office hours and mentoring. There is a reason people come to Williams to be professors. We love interacting with students. Many of us remember how much we benefited when we were students. When I was a freshman, I was absolutely terrified of going to professors' office hours at Yale. I figured they've got to have better things to do than talk with me. Yes, but part of what they are there for is that they want to talk to students. And of all the schools I've been at, Williams I think is the absolute best. The math stats department is physically structured to maximize this. I often have to walk through the library to get to my office. So she says, oh, good, Professor Miller's here. And somebody came by and we had a nice conversation yesterday for half an hour, going from mathematics to some RU programs to Supergirl. Take advantage. Try to get to know at least one professor well each semester. Doesn't have to be me. I don't mind if it is. Happy to do lunch, coffee, whatever. This way, if you're only 50% successful, when you graduate and you need letters of recommendation, you'll have 3 to 4 people who can write for you. You'll have people who know you, bless you, well enough that they can think, hey, this opportunity would be really good for so-and-so. So really take advantage of the fact that we want to chat with you. Also, this leads to potential thesis topics, or to doing summer research, or various projects. So there's a lot of good reasons. And the last is learn to manage your time. This is one of the most important skills to master. If you think life is bad now, if you think you're busy now, it's going to get a lot worse. Especially when you start having families, if some of you choose to go that route. Sometimes people end up becoming more efficient the more things they have going on. I know a lot of athletes do a lot better when they're in season than when they're not in season because they have so many things going on. If they are not very careful with their time, they're not going to survive. So really learn how to manage things. One of the things I strongly urge is never go 24 hours without responding to an email. It may be something really stupid as saying, got your email, slammed right now, we'll respond more in a week. But at least acknowledge things within a day. One thing which I would add, which my brother didn't directly say but he would agree with, is have good file names. Do not have resume.pdf, cv.pdf, paper.pdf. These are terrible file names that are recipes to get lost with other people's work. Have your last name somehow involved in it. If it's for a class, have that. You really want to have a good naming structure. I know strong Williams students who are moving up the corporate ladder. They love helping Williams students. But if they get a resume called resume or cv.pdf, if they want to forward it on to their boss, they've got to download it to their hard drive, change the file name, upload it back, and a lot of times they're so busy, they are running around 24/7. This person was borderline not worth it. And I know students who have missed for something like that. I know people who have missed out on NSF grant opportunities because they didn't check that when they recompiled, it went one line over the 2-page maximum. And the system automatically rejected them, but didn't tell them it was rejecting them for being one line over. Really look at the requirements. Really look at what you need to do. All right. And then the other thing is, I'm happy to do practice interviews. I'm happy to adjust deadlines. If you have a big play, sporting event, whatnot going on, we can move when a homework assignment is due. That's not a big deal. Preferably let me know beforehand. Beforehand means at least 24 hours. If you let me know 2 hours before the event, that's not enough time. But as long as you give me plenty of warning, I'm happy to work with you on stuff like that. All right, last thing is just a bunch of useful links, and again, all this stuff is online. I have a web page where I have some handouts on LaTeX, on Mathematica, some videos on stuff like this. Any file on my web page, all you have to do is change .pdf to .tex, and you'll have the text source code. You may not have the image files, but you'll be able to see how all the stuff is done. I have a bunch of handouts that I've collected over the years, and just a web page of some general advice. All right, so this is the boring class mechanics. And I think we did it in enough time we can actually do some math today. All right, any questions so far? All right, so now it's going to follow me as I try to, I should have had one of you disable this. Okay. Okay. Is it? Oh, actually, it's not putting on all the lights. Oh, half the lights are dead. That's why it's not going on. Okay. Is it in focus if I'm over here?
Yes.
Okay. So, how many of you have seen me do the chess problem with 5 queens? Okay, good. So everyone can play this game. So this has become my new favorite problem. I would love to see a solution to it. Now, I know the solution for 5 queens. I don't know the solution in general. The thought process behind it is absolutely wonderful, and it illustrates a lot of what's going on. So due to budget cuts, we can no longer afford an 8x8 chessboard. Okay? Maybe if Swarthmore and Amherst pay their dues, we'll be able to get those extra few rows. So we have a 5x5 chessboard. Does everybody know how a queen moves in chess? Queens can move diagonally, horizontally, and vertically. And the goal is I want to place 5 queens in such a way as to maximize the number of pawns I can safely place on the board. Let's say instead of trying to maximize, what else could I have tried to do? Instead of trying to maximize the number of pawns I can safely place, what could I try to do? Minimize. I want to kill pawns. I don't want any pawns to be able to be placed on this board. Can anybody give me a way to place 5 queens so that no pawns could be safely placed? Yes.
So the queens are friendly pieces or enemy pieces?
The queens are enemy pieces.
Okay, so then you just put them diagonally?
So one possibility is put them diagonally this way, diagonally that way. That would work. Any other ways to make sure that no pawn could be safely placed?
Just in a row.
In a row. What else?
Column.
Column. What else?
Any other way? Like, any way?
So this is an interesting question. Maybe no matter what we do, there will never be a way to place any pawns safely, because there's 5 queens. My kids have learned sometimes to be a little hesitant when I say, you want to play a new math game Daddy created? So later on this semester, we might play the triangle game, which no matter how poorly I play, my kids can't beat me. It's a rigged game. It's not quite as, it's a little bit worse than some of the Vegas games. Those are only strongly supporting the house. Maybe there's no way to place 5 queens so that any pawns are safe. Can someone give me another way to place 5 queens so that no pawns will be safe?
Just any way such that every row is a pawn.
Good. So one possibility is put a queen in each row. And now, that's not going to give us the entire set of ways, because I could have all the queens in one row. But if each row is represented, so how many choices do I have for the first queen? 5, second queen, 4, 3, 2, 1. So that's at least one possibility, or a whole slew of possibilities. So then the question becomes, is there a way? And there actually is a way to place 5 queens so that 3 pawns are safe. Now, what makes this a little bit unusual is that I'm telling you how many pawns can safely be placed. In the general problem, you're not going to have that information. If I give you the 8x8 board, the 2017 by 2017, why did I choose 2017? It's the year, right? So you often choose the year if you need a very large number to show it doesn't matter what value of n I'm using. I just need some big number that looks generic. If you're doing a problem competition, you should know a certain fact. Is the year prime? That might influence how some of the problems are written for that year. But I know that there are only 3 ways, that there are 3 pawns that can be safely placed. I'm going to tell you that. I want to find how to put the queens. So step 1 is to either solve the problem or come up with a way to solve the problem. I don't care if it's fast. I don't care if it's good. I just want a way to solve the problem. And then, once I know a way to solve the problem, if it's slow, I will look for a better way to solve the problem. Everybody here has done multivariable calculus? You've seen Green's theorem, Stokes' theorem? You may not remember them, but you've seen them at some point. Early in the semester, you might get line integrals to do where the professors know Green's theorem and you don't. And so we can very quickly check and see what the answer is without doing the line integral. So there's often faster ways to do things. But right now, let's find a way. How many places do we have for the first queen? How many? 25. How many for the next? 24, 23, 22, 21. So that's the number of possibilities to check. That's a lot. It's not horrible. A computer could do something like this. If you want to estimate this, if you call them all 20, 2 to the 5th is 32. And we would have 1, 2, 3, 4, 5 zeros. So just as a rough estimate, do you think this is high or low?
Depends what you mean.
Do you think this is higher, a lot larger or smaller than the true product?
The one on the top is higher.
Yeah, the one on top is larger because I've rounded each one down to 20. So, but if I had done 30, that would have been an overestimate, and then I would have had 3 to the 5th. But you can see your ballpark, it's something that a computer can do. So the idea to attack the problem is to use symmetry. So symmetry is one of my favorite examples of a proof technique. So this is not bragging, this is just a statement of fact. I believe I am the tic-tac-toe champion at the Williamstown Elementary School playground. I have never been beaten, I have been tied once. I believe so. It's kind of sad. But I mean, you also choose which kids you play with. And you get a reputation, so people are afraid to challenge you. Any idea why I'm so good at tic-tac-toe? So, does everybody know tic-tac-toe? Goal is to get 3 in a row, alternate X's and O's. How many opening moves are there for tic-tac-toe? 9. How many responses? How many responses to responses? How many responses to responses? And so, the number of paths to look at. I might have told you I had bad memory. I actually have memorized every single string of tic-tac-toe games. No. So let's look at this another way. How many opening moves of tic-tac-toe are there up to equivalence? 3. We have the corner move, we have the middle move, and we have the center move. So really there's only 3 opening tic-tac-toe moves. If I move in the corner, how many responses are there? 1, 2, 3, 4. There's 5 responses. If I move in the middle, 1, 2, 3, 4, 5. And if I move, I hope this is turning. All right. If I move here, then it's 1, 2, only 2 responses. So we go from 72 to 12. That's a factor of 6 savings. And it gets better the deeper you go in the game. So in terms of being able to learn how things are going, if I use symmetry, I can make my life a lot easier. I was just teaching how to solve 2x2 Rubik's Cubes at the elementary school, my daughter's 2nd grade class. And so she loves it. I pick up and I go up, left, down, right. And when I move around like this physically, she returns to where she started. Motion, it's commutative. It doesn't matter the order in which you do things. But on a cube, as you do these moves, you will not return to the same state. It's a non-commutative group that's going on there. If people want, this is a problem-solving class. I'm happy to have a day where everybody learns how to solve a cube. We can definitely do that so that you can leave Williams with a useful, marketable skill. How can we use that symmetry here? Well, we have to decide what really matters. When we're playing tic-tac-toe, do we care if we go in this corner versus that corner? Now, in the emails you guys sent me, I don't think anybody said that they were interested in biology. Is this correct? Okay, so there's something called chirality, where you could have compounds that are mirror images of each other. One cures you, one kills you. It makes a difference. But for something like this, when we're analyzing the game, you can imagine there's a giant mirror. And it doesn't really matter if I go here or here. Or I can rotate the board, or I can flip. What's interesting is if you flip, you might actually be moving through the 3rd dimension. And so you might be moving the board through a highest, doesn't matter. The problem I'm trying to figure out is what's the optimal strategy. I don't really care about which corner is gone. They're all equivalent for me. How could we use that here? Probably some connection. Yes?
I mean, if you want to do it the brute force way,
Mm-hmm.
you cut down from 25 moves to less.
Okay, so let's quantify less.
I think it would be just 1/8.
So you got to be a little bit careful. Why 1/8?
So the center one.
So the center one.
Is the,
Okay.
and then the one directly to the right is 2.
Okay.
And then the one directly to the right is 3.
Okay. You can do this extra. Okay.
And then the one below and to the right would be 4. The one directly to the right that is 5. And then the one below that is 6. And I think you covered.
And we've covered everything. So instead of having 25 moves, we have 6. So it's about 1/4 rather than 1/8.
Yeah. If you expanded it, it would kind of approach 1/8.
Right. Because this is where things get interesting because you have n squared squares. Which is larger when n is huge, n squared or n? N squared. When n is small, unless n equals 1, n squared is going to beat n. But in terms of by how much, the beating doesn't really take place until it gets sizable. So the fact that we have to worry about this double counting of the diagonal, it's going to be annoying for small things. And so in the limit, if you look at it this way, we have 4 big squares. and we take 1/2 of this one, and in the limit it will be a 1/8. So you'll be saving almost an order of magnitude in your computation. The problem is, this might actually be harder to code. Well, maybe not so bad. You choose the first one from here, and then you look at the remaining squares, and then you choose 4 randomly from that. And you go through all the different possibilities. Sometimes it is better to do a little bit inefficient approach because it's easier to code. But here, not so bad. So this is going to save us roughly a factor of 4 for this problem. In the limit, it will save us a factor of 8. This is worth doing. There is something else we could do to attack this problem. So here, this is great. Instead of putting down all the queens, you're looking at 25 possibilities. Now, one thing is, the queens don't have names. They don't have different properties. All I care about is where the queens are located. So when we were doing 25 times 24 times 23 times 22, we were saying if we put the first queen here and the second queen here, that's different than putting the first queen here and the second queen there. Does order matter? So how many ways are there to place 5 queens among the 25 squares? 25 choose 5. So we could do, 25 times 24 times ... That's one approach. The next is 6 times 24 times ... The next is 25 choose 5. These are all different ways to approach the problem. There is one more thing we could do which just really blows this problem out of the water. And it's a good idea here, but it may not be a good idea later. Yes?
Well, I guess maybe we can try to place the 3 points.
Excellent.
And then see if it's possible to fit 5 queens in.
Excellent. So that's called looking at the dual problem. So frequently in mathematics, it's often easier to look at a related problem and convert what you're given to something else. If I'm placing 5 queens such that 3 pawns are safe, that's the same as putting down 3 pawns and seeing are there 5 squares that aren't attacking them. Why would it be better to place 3 pawns than 5 queens? There's fewer things, yeah. So now if we place, so this is called duality. And I'm still focused. 3 pawns. So now it could be 25 times 24 times 23. It could be 6 times 24 times 23, or it could be 25 choose 3. Or we could do even better, not 6 times 24. There's only 3 things here. It's very similar to tic-tac-toe. If we put our first pawn in the center, we then have how many places for the next one? Break it up into cases. And so if you do this, it's not that bad to find the solution. The best way, I think, is to just write a computer program. And I strongly encourage you to write a computer program to do this. Now, what I would like to tell you is that I gave you the wrong problem. Something should seem a little artificial about this. What seems artificial?
Number 5.
Yeah. Anybody ever watch The Fifth Element with Bruce Willis? Good movie. And the number 5 occurs a freakishly large number of times in The Fifth Element. Well, it's probably not surprising given that the movie is called The Fifth Element. And yes, I did actually look to see how often other numbers appeared, and it was less as you would expect. Do you think there's anything special about the number 5? What should we have started with? 1. Okay? So when you're given a problem, one of the best pieces of advice I can give you is try to do something easier first, build intuition, and then once you have intuition, go from that. Now, your intuition can mislead you. All right. For those of you who are trying to decide whether or not this class will be challenging enough for you, we will do harder problems than this later in the semester. I'm going to give you a 1-by-1 board and give you 1 queen to place. and I want to know the maximum number of pawns you can safely place given any possible location of the queen. What's the answer? Okay, there's really not that much to do. All right, building on this remarkable success, we move up to a 2x2 board. How many places are there for the first queen? Up to symmetry. 1. So we can either do queen, queen up to symmetry, or we could do queen, queen. How many ways? 0. In the interest of time, I'm not going to do the 3x3. Also 0. How would today's lecture have gone if I started giving you the string 0, 0, 0 and asked you to predict what do you think is true for the 4x4? 0. Right? You'd be conditioned at this point to be saying it should be 0. So a lot of times as professors or if you're a marketing person, you can try to guide people to where you want to be depending on how you present information. Any stats majors here? A lot of great work in terms of how you manipulate statistics. And so I will try to remember to include one of my favorite video clips. It's from a British TV show called Yes, Prime Minister. And the chief administrative aide to the Prime Minister is very upset that the Prime Minister wants to do something, so he wants to thwart him. And so he's going to commission a poll to prove to the Prime Minister that the public doesn't support this initiative. And his assistant goes, well, how do you know what the public will say before you do the poll? He goes, oh, it's just a question of which misleading questions do you ask in the beginning? People do that? Well, not the reputable pollsters, but there's so few of them that we don't have to really worry. And they go through 2 different sets of 5 questions to try to get you to answer the question differently. How you are presented a problem is extremely important. And again, this is why I'm willing to spend a lot of time. We will cover less material in this than most of your classes. And I'm proud of this. I really want to spend time emphasizing points like this. It is so easy to have blinders on and not even be realizing it. Once we have a string 0, 0, 0, you're put in this mindset that, okay, now I think when I'm looking for 4x4, there probably shouldn't be a way to do it. And given that there shouldn't be a way to do it, that could actually color how I do my experiment. It could color how I do my analysis. It could color whether or not I think I see a mistake. I am a big Isaac Asimov fan. I'm a big science fiction fan. I'm a big fan of physics and astrophysics. One of the greatest examples of ass-kissing in the history of humanity was when Herschel discovered the planet Uranus. And he decided to name it after his sovereign, the King of Britain. The King of Britain thought that this was an absolutely wonderful idea. The rest of Europe had another view. And so eventually they decided to name the planet Uranus. Uranus was Saturn's father, Saturn was Jupiter's father. But it was a really nice. A couple of decades later, Newton's law of universal gravity is not doing a good job of predicting where Uranus should be. And it's been doing such a great job for so many other things for so long, people don't really want to chuck it away. Why might Newton's law be doing a bad job? One way is it could be wrong. And yes, it's wrong with general relativity. We'll ignore that. Why might Newton's law not be doing a good job predicting the orbit?
Because there's planets out there.
Maybe there's a big planet outside the orbit of Uranus, and it would have the most impact on Uranus and less of an impact on the other planets. And maybe when Uranus was discovered, that planet wasn't near it yet, so it wasn't really affecting it that much, and now they're in a part of the orbital cycle where it's close. And so without computers, the mathematicians, physicists, astronomers predicted where this planet should be. And unfortunately, there were 2 groups. It was the French group that was able to convince astronomers to turn their telescopes before the British group was able to. And so Leverrier was the one who predicted and had his prediction verified as to where Neptune was. And he became essentially a rock star of 19th century science. It's impressive to predict where a planet is with some scratches on a piece of paper. He then turns his work to Mercury. Mercury's orbit was a little bit off. Now imagine you've just predicted the existence of Neptune, which fixes the issues with Uranus. Mercury is a little bit off. What would you predict? What do you think he predicted? An inside planet. And this planet's going to be extremely hard to see because it's close to the sun. And it'll be very small, and since it's close to the sun, it will affect Mercury the most, and it will have very small perturbations on the other planets. Now, it's going to be extremely hard to see. You need to wait for certain types of eclipses and whatnot. But they predicted when you should look. And what do you think happened when people looked? Most people saw nothing. Some people saw a planet. And you again, Rockstar has predicted Neptune. Rockstar says there's a planet here. Do you want to be the first one to see it? Do you want to be the one whose observations are the ones that establish the existence of the planet? Interestingly named Vulcan, after the god of the forge. So a lot of people observed Vulcan. Most people didn't, but some people did. As the telescopes got better, they were able to say, well, look, if Vulcan exists, if it was this big, we would have been able to see it. And it keeps getting smaller and smaller and smaller until eventually it's maybe a couple of asteroids which don't have enough mass to fix what's going on with Mercury. And the solution comes with Einstein's theory of general relativity. The gravitational field actually has energy. Energy is equivalent to mass. And when you take that into account, it fixes Mercury and everything else. But it's the danger of preconceptions. It's the danger of looking at things and already having an expectation of what the answer is. That's why I wanted to start off with 5 and not color you. Sometimes it's actually worthwhile to start a little bit down the road because small numbers can be misleading. There's a lot of great questions that we will look at in this problem. My first question is, let's let f of n be the number of safe pawns when place n queens on an n by n board. So we'll call it the maximum. What can you say about this function, fn? It's not strictly increasing because it goes 0, 0, 0, then it goes 1, 3, 5. Maybe it's increasing from some point onward. Is there a way to take a configuration and expand it so that if I have 6 pawns safe on this board, if I add another queen in another row and column, I'll still have at least 6? In the limit, do you think 100% of the squares are safe? 10% of the squares are safe? 0% of the squares are safe? We have 3 pawns on a 5 by 5 board. Is that 60%? Or is this on the order of n over n squared, like 1 over n? Very tough to tell. So I have some partial results. I do know roughly how fn grows, but I would love to have a better answer. And so we'll talk about stuff like this. The last thing I'll just end with is if you have a string of integers, there's this fabulous website called the OEIS, the Online Encyclopedia of Integer Sequences. You can go online and put in your string of integers, and it will tell you all the strings of integer sequences it knows that start with that or have that as consecutive blocks. And it will tell you all the properties it knows about them. And this can be a great way to then refine your guesses to what the answer is. All right, so I hope this gives you some sense of what the class is going to be like. I will send you a little bit more detail as to what to be reading.